So this was the exercise. We started discussion organic chemistry questions over there. And we did question one. We will start with question two because question two we did not discuss completely. So we'll start with question two. Organic chemistry, this is an important topic. You will find greater weightage of the question from this topic. So compound X can be formed by dimerization reaction where two molecules of ethanol link as shown. Give a name of a compound. So what is the name of this compound? So when we when we draw consider the main, so this is first carbon, second carbon, third and fourth carbon. The third carbon is having a OH group. So when OH group is considered as a branch, we call that as a hydroxy. So this is 3-hydroxy. And because 1, 2, 3, 4 are there, so it will be but, single bond N, and due to aldehyde, it will be R. So it is 3-hydroxybutanol. The following 3-step mechanism suggested for this reaction, step 2 and 3 have some similarities to a reaction of aldehyde with hydrogen cyanide. Deduce the role of ethanol in step 1. So what is the role of ethanol in the first step? Because if you see, first we have OH here, and then when the reaction finishes, it becomes H2O. So it means it is giving out its proton. So when something donates proton, what we call that as acid. So it is acting like an acid. Because acids are proton donors. Next, complete step 2 of the mechanism, show the relevant curly arrows. So when we write the polarity, like oxygen will be partial negative, carbon will be partial positive. And you can see oxygen has an extra electron. So it means the arrow, the curly arrow, both should point towards oxygen, like oxygen took both of the electrons involved in the bonding. That's why the charge on oxygen will be negative. And whenever we draw an arrow, we draw an arrow from the electron pair or lone pair to the partial positive. So the arrow from the lone pair should be pointed towards the carbon partial positive, and they link with each other. Next is deduce the type and the mechanism of overall reaction. So what kind of reaction is this? Because it is attacking on the positive center, so it is nucleophilic. And mechanism, like whether it is addition or substitution, because one product is formed, so when one product is formed, so the mechanism will be addition. So type of a reaction can be nucleophilic or electrophilic, and mechanism, it might be addition. How you know addition? If there is only one product, it will be addition. Then state the role of hydroxide suggested. As you can see, when we use a hydroxide from the beginning of experiment, the hydroxide is used here, and after the reaction, hydroxide is being released. So what hydroxide is acting like? Hydroxide is acting like a catalyst, because before and after it is same. So state the overall role of hydroxide and suggest that mechanism, justify your answer. So you'll mention hydroxide is acting like a catalyst because it is regenerated, or when the reaction finished, it regenerated at the end of reaction. Explain why a sample X produced by a reaction B does not rotate the plane polarized light. So there might be two reasons for not rotating a plane polarized light. One is maybe the product does not have any chiral carbon, or the second possibility, it might produce optical isomer, or it may have a chiral carbon. but it might result in a racemic mixture. So both possibilities are there. So when you check, because uh, when this group is trigonal planar, like 3 bond pairs are there, like even though overall 4 bond pairs are there, but when there's a double bond, we consider as one. So this one, if we consider as 1, 2, and 3, so 3 bond pair, the bond angle will be 120. So aldehyde and ketones, they all are trigonal planar. So when they are trigonal planar, it can attack from any side, like it can attack from left, so it might result in a formation of a racemic mixture. It is having a chiral carbon. There is a chiral carbon here. You can see this is a chiral carbon because different groups are attached to that. So it is a chiral carbon. So if it's a chiral carbon, why it does not rotate the polarized light? Because you will mention the aldehyde group, C double bonded with O and H, or you can say a carbonyl group is a trigonal planar. So it has both possibilities that um, like attack can occur from above or below. So both sides it is possible, or as it is a planar carbonyl group, and this will result in a formation of a racemic mixture. So answer, this is a very common question. So answer here, carbonyl group is trigonal planar. Attack can happen from above or below. And what will happen? This will result in formation of 2 enantiomers or racemic mixture. So carbonyl groups always result in a formation of a racemic mixture when there's a nucleophilic attack on the carbon. In part C, at low concentration hydroxide, the rate of a reaction for this reaction is, so look, if a rate of a reaction depends on presence of both hydroxide and the substance, the concentration of ethanol is 0.2. The concentration of a sodium hydroxide is 0.04. The rate of a reaction was this. Calculate the value of a rate constant. So the concentration of a hydroxide means like sodium hydroxide is the concentration of OH. So rate is 8.8 into 10 to the power minus 3. The values are given. K we don't know. The concentration of aldehyde, ethanol is given 0.2. And the concentration of hydroxide is same as the sodium hydroxide. So this is multiplied, other side it will be divided. This will give us a value of K. So value of the K will be equals to 1.1. But the second mark is for writing the unit of the K. So how we work out the unit of a K? The unit of the rate is moles per decimeter cube second. The unit of a concentration is moles per dm cube. And this also moles per dm cube. So when we simplify this, dm cube will cancel with dm cube, mole will cancel with mole. So here we are left with 1 over second, and here we are left with K is equals to mole divided by dm cube 3. So dm cube 3 is multiplied and mole is divided. So it will be dm cube 3 and mole inverse will be there, second inverse. So this will be the unit. So 1 mark is for the answer, like the value 1.1, and another mark is for the unit. Give a reason why the rate equation suggests that step 1 is a rate determining step. So look, rate determining, like as you can see in the beginning of question, this reaction happened in 3 steps. So why step 1 is a rate determining step? Because you can see both aldehyde and OH are included in step 1. If step 2 was a rate determining step, then only aldehyde should be included. If step 3 was a rate determining step, then this should be included. But because in a rate equation, as they give us that rate is equals to K times the concentration of aldehyde, ethanol, and the concentration of OH. So both reactants are involved in the rate equation. That's why step 1 is a rate determining step. Moving on to question 3. This question is about the organic reactions shown in the diagram. So first we have a butanone is there. We have ketone. A ketone is converted into carboxylic acid. But a reagent P and Q and then reagent R, and it turned into propanoic acid. So initially it is butanone, like butanone means like 4 carbon atoms are there. But when the reaction finished, we are left with 3 carbon atoms. So means one of the carbon atom is being removed. That's why like it is forming propanone, propanoic acid. And it is forming triiodomethane. So what this gives an idea? It gives an idea like iodoform test is done, like adding sodium hydroxide and iodine. Then propanoic acid converted into propanol. So it is by reduction. And then propanol is converted into propanol, propan-1-ol converted into propanol. It means it is by um, uh, like oxidation, partial oxidation. Propanoic acid is converted into the acyl group. So usually it is by PCl5. And propanoic acid is converted into ester. So it is by reacting with alcohol and then reacting with ammonia, a new compound. Now, name a reagent PQ used in reaction 1. So this is related to memorizing the conditions. So what we use, because triiodomethane is also formed. So we react like P is actually aqueous sodium hydroxide, and the other one is iodine in aqueous potassium iodide, or iodine in a potassium iodide solution. So what is P? P should be aqueous sodium hydroxide. What about Q? Q is iodine in aqueous potassium iodide solution. Then identify R used in reaction and why it is needed. So what is a substance R? So normally for this we need an acidic condition. So normally like you can mention nitric acid, you can mention hydrochloric acid, or you can mention sulfuric acid. Any strong acid you can name here. Aqueous acid is used. And what is the purpose of this? Basically the acid will protect, like because when an iodoform reaction is done, it will form a sodium propanoate will be there, the product. And then the product is sodium protonate. So we add, like we replace this sodium, like when this reaction will happen here or occur, without, like if only P and Q were there, then what is this product? This product will be ONA, like this is negative, this will be positive, and then triiodomethane will be there. If only we use P and Q, like adding a sodium hydroxide followed by iodine and aqueous potassium iodide. And if R was not added, so it will form this product. Now, to remove this sodium, so we use any strong acid, like example, a hydrochloric acid, sulfuric acid, or a nitric acid. And what it will do, it will remove this sodium, like this proton from acid will remove the sodium. So what is the, identify the reagent? use in reaction one, what reagent we use? We use like you can mention nitric acid, sulfuric acid, or hydrochloric acid, aqueous. And what is the purpose of that? It is to protonate sodium propanoate. Like adding a hydrogen to sodium propanoate. Is it clear? Name the second product in reaction one. So what is this product? This is called a triiodomethane. And triiodomethane is used to test like if there's a carbonyl group, methyl group next to carbonyl group. So triiodomethane you can also say, or the iopic name is 111 triiodomethane you can also say. But even iodoform is acceptable, triiodomethane is acceptable. Identify the reagent and the solvent required for reaction 2, stating the essential condition. For reaction 2, because we are converting a acid into alcohol, so it means a reduction is done. And how a reduction is done? So we use lithium tetrahydrodualuminate 3 is used here. And in a dry ether, we use in a dry ether the essential condition. So for reaction 2, because it's a reduction reaction, so for reducing agent, we use lithium tetrahydrodualuminate. And in what condition we use? It is used in a dry ether. The reagent used in reaction 3 are potassium dichromate. Potassium dichromate is an oxidizing agent, and a sulfuric. How this reaction must be carried out? Ensure. Look, we want to carry out a partial oxidation. As you can see, alcohol, because alcohol, primary alcohol can be oxidized to aldehyde, and aldehyde further oxidized to carboxylic acid. So we want a partial oxidation. If we want a partial oxidation, then what we should do? We should distillate the product immediately out of the reaction. Like we just allow the product to escape. So state how the reaction must be carried out. So we should distillate the product. Identify the reagent required for reaction 4. What is reaction 4? Reaction 4, propanoic acid is converted into acyl chloride. So how it can be converted? So we can use a PCl5, phosphorus pentchloride, or phosphorus trichloride can also be used. So phosphorus pentchloride. Name a compound X formed from reaction 6. Which compound is formed in reaction 6? So what actually happened, like in ammonia, it is NH2NH. This is partial negative, this partial positive, this is partial negative. So NH2 will take position. So what will be the product? So this will form an amide. And what we call, because 3 carbon atoms are there, so it will be propanamide. Like this product will be propanamide. So the product is propanamide. Then mass spectrometry and infrared spectroscopy are used to analyze a sample of butanol and propanol. The base peak, the tallest peak, is in a mass spectrum of butanol is at 43 and a base peak of propanol is 29. Base peak means the one which we get the maximum amount. That's called a base peak. So like most of the molecule break down into that. So how we can identify? If we break down in butanol, CH3, C double bonded with O, CH2 and CH3. And for propanol, CH3, CH2, C double bonded with O and H will be there. So when we write the product like this is 15, this is 16 plus 12 makes 28. This will be 14 and this will be 15. Here this is 15. This will be 14. 16 plus 12, 28. And this will be 1. Usually like 29 you can also say. So in the question they're asking like which is giving us the base peak. For 43, like how it will get 43? If we read from left to right, like you can make different combination. First from left to right, so what are the peaks it will give? I'm writing it here. This will give 15 or 15 plus 28 makes 43. So we got 43. So it means the peak 43 from butanol is due to CH3, C double bonded with O. And there's a plus charge. Why I did not check from other side? Because if I get the answer from this one, so I don't have to do it for all. Because this sum is making 28. If it was not making 28, then I'll check that another option. But don't forget to write the plus charge because we have to identify the species. So there must be a positive ion, a cation must be there, which are identified. And for propanol, it's 29. So if I read 15 plus 14, so 15 plus 14, this is making 29. So I can say CH3, CH2, and that is responsible for giving 29 here. So I don't have to check other, even there will be 29. If I read from here, there will be 29 as well. But because they just asked, because there are many peaks which might result in 29. So if I get one answer, I don't have to do the whole question. I just move on to the next one. Explain by quoting the value from a data booklet how infrared spectroscopy could be used to distinguish between butanol and propanol. Infrared spectroscopy is used to identify the bonds. So how you can distinguish, like what is the difference in the bond here? And you from your data booklet. So even the bonds appear to be same, like or bond appear to be same. But if we have C double bonded with O, if we have C double bonded with O and it belongs to aldehyde, will absorb different energy as compared to C bonded with O from ketone. So from a ketone, it is like 1000. So from a ketone, it will have like 1700 to 1680. For aldehyde, this peak is 1740 to 1720. And there's also CH peaks are also there. Usually for aldehyde, the CH peaks for aldehyde, it is from 2900 to 2820. Bonds are identical, but because their environments are different, as a result, when the environments are different, it will result in a different absorption. So sometimes we may have the same bonds, but different absorption because of their environment, the surrounding molecule. Full equation for a reaction 5 is shown here. Give an expression for Kc. So how to we write the Kc? Kc is a product divided by reactant. So means CH3. This is a homogeneous equilibrium, means all of them have the same state. So we include all of them. But what if like one was all of like most of only one was gas and all were liquid? So then we'll only include the gas. When this reaction is carried out in the lab, small amount of sulfuric acid is added. State the role of sulfuric acid. What is the role of a sulfuric acid for esterification? So sulfuric acid is actually used as a catalyst to form ester because it increases the amount of proton, so it favors the forward reaction. But overall amount does not change for hydrogen ion. That's why we say it is acting like a catalyst. In an experiment to determine the equilibrium constant, 18.5 grams of a propanoic acid, 23 grams of ethanol, 36 grams of water were mixed together. Small amount of sulfuric acid is added. After several days, equilibrium contain 0.14 moles of propanoic acid. Calculate the equilibrium constant Kc. And it's such a 5-mark question. So if their masses are given, first you'll find the initial moles. Say we have C2H5 COH. We have C2H5OH, the reactant. Then ester is there, C2H5 COO, C2H5 plus water is there. And in the beginning, masses are given. We have like 18.5 of this. We have 23 grams of this. We don't have the ester, and we have 36 grams of water. First, we find the moles. How to get the moles? We divide it by the molar mass. This one is 74. So this will give us the initial moles 0.25. When we divide, this will divide it by 46. So we got the initial mole 0.5. This will remain 0 and this will be divided by 18. So initial mole 2. These are the initial moles. But at equilibrium, how many moles were found? We found 0.14 moles of propanoic acid. So 0.14 moles are there at equilibrium. So how many moles are used? Because like how many moles are reacted? If 0.14 are we found at equilibrium, so how many moles are used? So 0.11 moles are used. And the ratio between the carboxylic acid and alcohol is 1:1. So same number of moles will be used. But we don't need how many used, we need how many left. So 0.5 minus 0.11. So how many moles are there? 0.39. For ester, because there is 0 moles, so 1:1 is the ratio, so it will give 0.11. And water also 0.11, so it will become 2.11. So this will be added 0.11. This will also be added 0.11, but this is subtracted. So we don't need how many are reacted. We need how many are left. So first we found how many are reacted and taking a ratio to find how many moles of reactant are reacted and how many moles of product are formed. And at equilibrium, for getting the moles of the reactant at equilibrium, we add, and to get the moles of a reactant of a product at equilibrium, to get the moles of reactant at equilibrium, we subtract, and to get the moles of product at equilibrium, we add. And we just substitute in the equation and we'll get the value for Kc. In part D, propanoic acid also react with chlorine in the presence of UV to form a 2-chloropropanoic acid. What information suggests that the mechanism of this reaction involves free radical? Because what we are doing, we are using a UV light. Ultraviolet light is used to break the bonds and make a free radical. So what information give us suggests that the mechanism involves free radicals, that is the ultraviolet light. Draw structure of free radical formed from propanoic acid. So like what free radical can form from the propanoic acid? The whole structure is same, only this, you can see that like here 2 hydrogens are there and here 1 hydrogen and 1 Cl. So means this will break down into CH3, CH, COH radical plus H radical. But we just need a radical form from propanoic acid. How we identify that this one should break down? Because when you check the product, only 1 hydrogen is there and the chlorine is added. So means one of the hydrogen is being removed. So it must form a free radical in this manner. Why the product of this reaction has no effect on the plane polarized light? As I mentioned, there might be 2 reasons for not affected by the plane polarized light. One is it may not have any chiral carbon, or second is it may result in a formation of a racemic mixture. So if you check, is there a chiral carbon here? So when we draw the structure of a product, this is CH3, this is CHCl, and this one is C double bonded with ONOH. So this is not a chiral carbon because to be a chiral carbon, so this is a chiral carbon. So 1, 2, 3, and 4 different groups. So there is a chiral carbon. So means there is like it should rotate the polarized light. But why it is not rotating the polarized light? What might be the reason for that? The reason again, when it will form, as you can see, like when it will break down, this molecule will break down, 1 hydrogen is removed. So this will be CH3, this will be CH, and then C double bonded with O and H. This is a free radical which is produced. So now the chlorine radical can attack from top or it can attack from the bottom. Both ways, both possibilities are there. So the free radical which is formed in intermediate, that is trigonal planar, and when it is trigonal planar, there are both possibility that it can be attacked from the top or the bottom, which result in a racemic mixture. So you'll mention the points, like how you score the 3 marks. You will mention first thing, the free radical which is formed in the intermediate state is a trigonal planar. Because it's a trigonal planar, so the chlorine free radical can attack from the top or from the bottom, or either side you can also write. And that will result in the equimolar mixture of enantiomers, which plane polarized light rotate equally in opposite direction, so they cancel out each other. So the intermediate free radical is planar. That is one thing. Then attacking free radical can attack from either side, which result in formation of racemic mixture. And as a result, when it will form a racemic mixture, then what will happen? It will not rotate the polarized light. Like one is rotating clockwise, another one is anti-clockwise. So overall, they cancel out the effect. So this was question 3 from this exercise, organic chemistry.